recapping with asymptotes. Today we will be finding the horizontal asymptotes and also the vertical asymptotes from the equations. And the first thing that we'll have to do is do a little bit of factoring review so that we can find where those asymptotes would be. So looking at number 1, we have 4x squared plus 10x, and we need to factor that. So when you're factoring, what's the first thing you should look for? Common factor, the greatest common factor. So what's the biggest number that goes into 4 and 10? 2. Now both of these have an x, and remember with variables you take the lowest power, so the smallest power is x to the first. So the GCF is 2x, it goes in front of the parentheses. Now 2x times what gave us the 4x squared? 2x. And 2x times what gave us the 10x? 5. Next one, number 2. Now we're factoring with a trinomial, and it's a 1x squared. So if you remember, we need to find two numbers that multiply to 8 and add to -6. So out to the side, if I list out my factors of 8, I could have 1 and 8 or 2 and 4. Now we need to add to the middle number, which is -6. So which pair adds to 6? 2 and 4. But right now it's positive 6, so I need to make both of these negative. So what's one of the binomials? X minus 2. What's the other one?
X minus 4.
X minus 4. Number 3 is the same thing. We have a trinomial with a 1x squared out front. So I need to find two numbers that multiply to -100 and add to 48. So factors of -100. I could have -1 times 100, -2 times what? And what does that add up to? 48. What's 50 minus 2? 48. Is that what we're looking for?
Yeah.
Yeah, that was one of the answers. X minus 2. What is the other answer? X plus 50. Next one, number 4. Now this is a 3x squared. So if it's bigger than a 1x squared, we'll have to use that AC method. Remember, you multiply the A value times the C value. And what is 3 times 5? 15. So factors of 15, I could have 1 and 15, or 3 and 5. Add up to the middle, and what's the middle number? 16. So which pair do I have to use? 1 and 15. Now we're about to factor by grouping. So we're going to split up the 16x. We're going to use these two numbers here. We'll use a 1x and a 15x. So this would be 3x squared, and then use these two values. So this would be plus 1x plus 15x plus the constant, which is 5. So break up the middle term using the two numbers you found. Now we're ready to group them. So group the first two, group the last two. What's the GCF for the first group? X. What goes in the parentheses? 3x plus 1. What's the GCF for the second group? Positive 5. And what goes in the parentheses? 3x plus 1. So what's one of the answers? 3x plus 1 is my common binomial factor. What's the other answer? The GCF, which is x plus 5. So 3x plus 1, x plus 5. Number 5, we have x squared minus 16. What is that binomial called? Difference of squares. So put your two sets of parentheses. And since these are perfect squares, square root them to get your answers. What's the square root of x squared?
X.
So we'll have x and x. One is a minus, the other is a plus, and square root of 16. Square root of 16 is 4. So x minus 4, x plus 4. Now, getting into some asymptotes. Now, inside this table, let me see if I can shrink this because it's kind of on the screen. There we go. Okay, so it tells us to look at f of x equals 1 over x minus 4 on the graph on the calculator. So that's the first thing we need to do here is we need to go ahead and put this in the calculator. So go ahead and go to a graph page. And do control divide for a fraction, 1 on top, and x minus 4 in the denominator. Then hit enter, and where is the fourth, Is it x plus 4? Okay, let me fix that. So on your handout, it's plus 4. So if I make it x plus 4, it's definitely going to change my graph. So looking at this graph, I do see that there's an asymptote. And remember to find your asymptotes, you're looking for the flat part. Let me see if I can do a screenshot of this. Okay, so when you're looking for the asymptotes, you're looking for the flat part of the graph. And where's the flat part of the graph for the vertical asymptote? What number is it falling at? -1, -2, -3. -4 would be where that vertical asymptote is located. What about the horizontal asymptote? It's getting flat right here at 0. So with this rational function, we have two asymptotes. The vertical asymptote at -4, and that horizontal asymptote at 0. So let's go back and answer the questions they gave us pertaining to that graph. And they asked us, what is the vertical asymptote? So what's the equation for that vertical asymptote? It's going through the x-axis at what value? -4. And on yours, this is a plus. And it says, look at the table. Where is the error? So we forgot to do that. So looking at the table, how do I pull up the table? Control T. So control, then the letter T. And to find the error, where do you see the error? At -4. So it's undefined at -4. So that's when x equals -4. And that's the equation for the vertical asymptote is x equals -4. So that means our domain is all real numbers except x cannot touch what value? -4, where that vertical asymptote is located. Now, notice in my equation, if I put a -4 right here for x, what's -4 plus 4? 0. So this would be 1 divided by 0, which is what? Undefined. So you'll have a vertical asymptote anytime this denominator equals 0. Okay, problem 5, actually number 6. The first thing we have to do is find the domain, but before you can find the domain, you'll actually have to find your vertical asymptote. So you'll probably want to make yourself a note somewhere to find the vertical asymptote. Again, we use VA for vertical asymptote. So to find the vertical asymptote, set the denominator equal to 0. So to find the vertical asymptote, set the denominator equal to 0. So to find the vertical asymptote, set the denominator equal to 0. So let's look at number 6. To find that vertical asymptote, set the denominator equal to 0. So here's my denominator. It's x plus 3. So you need to take x plus 3, set it equal to 0 to find that vertical asymptote. And the next thing you have to do is after you set the denominator equal to 0, solve for x. So how do I get rid of the plus 3? Minus 3 to both sides. And that gives us x equals negative 3. So there's the equation for the vertical asymptote. It's x equals negative 3. Now your domain is going to be all real numbers except where that vertical asymptote hits. And where will that vertical asymptote hit? Negative 3. So the domain is all real numbers except x cannot equal negative 3. So find your vertical asymptote first to figure out what value has to be excluded from the domain. Number 7, to find your vertical asymptote, set the denominator equal to 0. So in the denominator I have x minus 7. So take the x minus 7, set it equal to 0. And solve for x, so what will we have to do to get rid of the minus 7? Add 7 to both sides. So what would be the equation for that vertical asymptote? X equals 7. So x equals 7. So that means our domain is all real numbers except x cannot equal 7. Then number 8. How do I find the vertical asymptote? Set the denominator equal to 0. So in the denominator, I have x squared minus 9, set it equal to 0. Now we need to solve for x. So what can I do to solve for x? Add 9 to both sides. So that gives me x squared equals 9. And how do I get rid of the square? Square root both sides. So x equals, what's the square root of 9?
3.
Positive and negative 3. So this one has 2 vertical asymptotes, positive and negative 3. Now because of the square, that's why we have 2 asymptotes. So if this is the second power, you'll have 2 asymptotes for the vertical asymptote. So that means our domain is all real numbers except x cannot equal what? Positive or negative 3. So all real numbers except x cannot equal positive or negative 3. Okay, next one, number 9. How do I find the vertical asymptote? Set the denominator equal to 0. So I need to take x squared minus 2x minus 8, set it equal to 0. Now this one, I can't just add 8 to both sides because then I'd have an x squared and an x, so that won't help me. So what I need to do here is solve by factoring. So go ahead and put your 2 sets of parentheses, and that's why we did those first 5 problems. We reviewed our factoring skills so we could do this. Okay, so now I need to find 2 numbers that multiply to negative 8. So we're going to have negative 1 and 8, negative 2 and 4, negative 4 and 2, negative 8 and 1. What do I need to add up to? Negative 2, so which pair adds to negative 2? Negative 4 and 2. So one of these will be x minus 4. The other will be x plus 2. And after I have it in factor form, what do I have to do Do you remember? Set both factors equal to 0. So x minus 4, set it equal to 0. And x plus 2, set it equal to 0. So what's the first vertical asymptote? X equals 4. And over here, when I subtract 2, this would be x equals negative 2. And no, that one's not plus or minus 4 because we didn't square root it.
Oh, okay.
So over here we have two asymptotes, so because of the square, you'll have two vertical asymptotes. So the first one is x equals 4, the second one is x equals negative 2. So that means my domain is all real numbers except x cannot equal 4, and x cannot equal what? Negative 2. So x can't be 4 or negative 2. Okay, the next one, number 10. How do you find the vertical asymptote? Set the denominator equal to 0. So this would be 3x squared plus x minus 4 equals 0. Now this one is bigger than a 1x squared, so we'll have to use the AC method to multiply the 3 and negative 4. So it's 3 times negative 4. Negative 12. So we need two numbers that multiply to negative 12 and add the positive 1. Is it negative 3 and 4 or negative 4 and 3? Negative 3 and 4. So when I split up the middle term, this would be 3x squared minus 3x plus 4x minus 4 equals 0. Once you have your four terms, group the first two, group the last two. What's the GCF for the first group? 3x. What goes in the parentheses? X minus 1. What's the GCF for the second group? Positive 4. What goes in the parentheses? X minus 1. Then the two factors, the first one is x minus 1. What's the other factor? 3x plus 4. And once we have these in factors form, what do we have to do next? Set them equal to 0. So x minus 1, set it equal to 0. 3x plus 4, set it equal to 0. And when I add 1, what's the equation for the first asymptote? X equals 1. And over here, what would I have to do first for the 3x plus 4? Subtract 4 to both sides. So 3x equals negative 4. Divide both sides by 3. And x equals negative 4/3. Okay, so the first vertical asymptote, I lost my place. Let me change to red. So the first vertical asymptote is x equals 1. The second vertical asymptote is x equals negative 4/3. So that means our domain is all real numbers, except x cannot equal what? 1 and what else? Negative 4/3. Okay, I want you to do number 11. I want you to find the vertical asymptote and the domain. Okay, number 11. Set the denominator equal to 0. So the 5x squared minus 16x, set it equal to 0. And that one has a GCF. What's the GCF? 5x. And what goes in the parentheses? X minus 3. After you have it in factor form, set your factors equal to 0. So 5x, set it equal to 0. X minus 3, set it equal to 0. Divide both sides by 5 for the first equation. And what's the first asymptote? X equals 0. Over here, add 3 to both sides. And what's the second vertical asymptote? X equals 3. So the vertical asymptote, I need to write this as x equals 0 and x equals 3. So that means the domain is all real numbers except x cannot equal what? 0 and 3. Okay, any questions on the front? Moving to the next page. Now on the next page, you need to make yourself a note that you need to memorize these 3 rules. Our test will be next Friday, so make sure you memorize these 3 rules. So when they're talking about the degree in the top and the degree in the bottom, they're talking about just the power. So what's the highest power in the top of the fraction? What's the highest power in the bottom? So the first rule shows that the degree in the top is bigger than the degree in the bottom. So for an example, if I had x cubed over x squared. So when they're talking about the degrees, they're talking about the exponent. So for the top, the power is 3, and the bottom, the power is 2. So notice the top exponent is bigger than the bottom exponent. So when that's the case, you will not have a horizontal asymptote. So HA stands for the horizontal asymptote. So if this is the case, if the biggest power is in the top, there won't be a horizontal asymptote. Rule number 2, if the degree in the bottom is bigger than the degree in the top. So this time, if the x cubed is in the bottom and the x squared is in the top. So if the bigger degree is in the bottom, we call it bottom heavy. So if it's bottom heavy, then your horizontal asymptote is y equals 0. And for the last one, if the degrees are equal, so that means I had x cubed over x cubed. Notice the degrees are the same. So if the degrees are the same, then your horizontal asymptote is y equals, and it's the ratio of the leading coefficient of those matching degrees. So the leading coefficient just means the number in front. So if we have x cubed, what number is in front of the x cubed? A 1. And this one would also be a 1. So my equation for the horizontal asymptote would be y equals 1 over 1, which is just 1. So it's just the ratio of the coefficients. So again, to recap, if the degree in the top is the biggest, then you do not have a horizontal asymptote. If it's bottom heavy, which means the biggest degree is in the bottom, then your horizontal asymptote is y equals 0. But if the largest degrees are the same, then it's y equals the ratio of the coefficients. Now for this example, it's 1 over 1. It's not always going to be 1 over 1. Like if I had x cubed over 2x cubed, what would be that equation? It would be y equals what? 1 over 2, or 1/2. So it's not always 1 over 1. Okay, some more examples. Now, we need to find the domain vertical asymptote. So the first two are the same we just did. but now we're adding in the horizontal asymptote. So let's go ahead and find the horizontal asymptote. So to find the horizontal asymptote, you look for the biggest degree. Well, in the top, the biggest degree is x to the first, right? What about in the bottom? What's the biggest degree? X to the first. So is it top heavy, bottom heavy, or are they equal? They're equal. So if I use my rules, if the degrees are equal, then it's y equals the ratio of the coefficients. So for the horizontal asymptote, here we go. This would be y equals, and then we need the ratio of the coefficient. So what number's in front of the x? A 1. What number's in front of the x? A 1. So it would be y equals 1 over 1, which is just 1. So y equals 1 is the horizontal asymptote. Now the domain and range is the same, not the domain. The domain and vertical asymptote are the same we've been doing. So find the vertical asymptote first, and how do you find the vertical asymptote? Set the denominator equal to 0. Subtract 2 to both sides, and what would be that vertical asymptote? X equals -2. So our domain would be all real numbers except x cannot equal what? -2. Next one. To find the horizontal asymptote, look for the biggest power. So in the numerator, what's the biggest power? It's x to the first. X to the first. What's the biggest power in the bottom? X squared. So where's the bigger power? Top or bottom? Bottom. So this is called bottom heavy. If I go back to the rules, if the bigger degree is in the bottom, what do I put for the horizontal asymptote? Y equals 0. Those of you going on to pre-cal, keep these memorized. You'll need these for pre-cal. And then the last part, now I need to find the vertical asymptote. And how do I find the vertical asymptote? I'm just going to go ahead and put equal to 0 right here. So set your denominator equal to 0. Now this one has to be factored. And how many vertical asymptotes will we have? 2. If it's squared, you'll have 2. So we need to find two numbers that multiply to -3. Well, that could only be -1 and 3, or -3 and 1.
1 and 3.
-1 and 3 adds to +2. So we'll have x minus 1, x plus 3. After I have it in factored form, what do I do next? Set them equal to 0. So x minus 1, set it equal to 0. X plus 3, set it equal to 0. So what's the first vertical asymptote?
1.
X equals 1. And what's the second vertical asymptote? X equals -3. So write those on the blank. X equals 1 and x equals -3. So that means the domain is all real numbers except x cannot equal 1 or -3. I'll just put 1 comma -3. Let's go right. Okay, number 14. Okay, next one. Now, to figure out about the horizontal asymptote, look for your biggest power. Where's the biggest power for the numerator? I mean, what is the biggest power for the numerator? X to the third. What's the biggest power in the bottom? X squared. So where's the bigger degree, top or bottom? Top. So if it's top heavy, what's the rule? That means it has no. So for the horizontal asymptote, write the word none. Don't leave it blank. You need to write the word none. And how do I find the vertical asymptote? Set your denominator equal to 0. So when I factor that, actually, how would I factor that?
Oh, that's how we do it.
X is D, G, C, F. So factor out the X, and what would go in the parentheses? X minus 4. And after you have it in factored form, what's next? Set them equal to 0. So the first one, set X equal to 0. There's the first vertical asymptote. X minus 4, set it equal to 0. And what's the second vertical asymptote? 4. And how did I know that we would have two vertical asymptotes? It was squared in the bottom. So the first vertical asymptote was X equals 0. And the second one is X equals 4. So that means our domain is all real numbers, except X cannot equal 0 or 4. Next one, number 15. Where's the bigger, actually, looking at the numerator, what's the biggest power for the numerator? X. What's the biggest power for the denominator? X squared. So where's the biggest power, top or bottom? So if it's bottom heavy, what's the horizontal asymptote? Y equals 0. And how do we find the vertical asymptote? Set the denominator equal to 0, and yes, that's a difference of squares. And when you square root those, what's the square root of x squared? So I have x and x, one is a minus, the other is a plus, and what's the square root of 49? 7. So x minus 7, x plus 7. And what do we do next? Set them equal to 0, so x minus 7 equals 0, x plus 7 equals 0. What's the first vertical asymptote? 7. What's the second vertical asymptote? Negative 7. So instead of writing this down as x equals 7, x equals negative 7, how could I write that? X equals plus or minus 7. So that means the domain is all real numbers, except x cannot equal plus or minus 7. Okay, the last 3 problems, we're doing the same exact thing, plus what's the extra step? Graphing it. So we're combining what we did today with what we did yesterday. Okay, so for number 16, first thing, let's go ahead and do the horizontal asymptote. So where's the biggest power, top or bottom? Bottom. Bottom. So if it's bottom heavy, it's y equals 0. So for the horizontal asymptote, it's y equals 0. So that means my range is all real numbers, except y cannot equal 0. So once you have the horizontal asymptote, go ahead and fill out the range. How do I find the vertical asymptote? Set the denominator equal to 0, so x plus 2. Set it equal to 0. So what would that vertical asymptote be? X equals negative 2. So that means our domain is all real numbers, except x cannot equal negative 2. Now, to graph it, what you need to do first is you need to graph your asymptote. You draw a vertical asymptote at negative 2. So you have a vertical line going through the x-axis at negative 2. So draw the asymptotes first. And then the horizontal asymptote is at 0, so go through the y-axis at 0. Now yesterday, go don't put these points here because they're wrong. Yesterday we found where the asymptotes intersect, we went over one up one and over one down one. But that's because we had a 1 in the numerator. Do we have a 1 in the numerator?
No.
No. So this is actually stretched by a factor of 3. So instead of going up 1, what is 1 times 3?
3.
So what's 1 times 3? 3. So that point actually goes up to 3. And this point, instead of going down 1, how many does it have to go down? 3. So over 1, down 3. And draw a curve going through that point. So here's curve 1, put arrows. And here's curve 2, put arrows. And will these curves ever cross those asymptotes? No. So don't have those curves go across those blue dash lines. Next one. What's the biggest degree for the top? X to the first. What about for the bottom? X to the first. So what do you notice about the degrees? They're the same. So it's going to be y equals the ratio of the coefficients. Yes, we have a 1 and a 1. So this would be y equals 1. So that means the range is all real numbers, except y cannot equal what value? 1. So once you have the range, once you have the horizontal asymptote, go ahead and put in the range. Now, how do we find the vertical asymptote? Set the denominator equal to 0. So x minus 1, set it equal to 0. So what would the vertical asymptote be?
1.
X equals 1. So that means the domain is all real numbers, except x cannot equal 1. Now make sure with these asymptotes, make sure for the vertical asymptote you have x equals. Make sure for the horizontal asymptote you have y equals. Don't just put the number, it has to be even in your equation. Now when you're graphing these, graph the asymptotes first. So for the vertical asymptote, go through the x-axis at 1. And for the horizontal asymptote, we need to go through the y-axis at 1. And put your points, so where they intersect, go over 1, up 1. Find where they intersect, go over 1, down 1. And make your curve through those points. So here's curve 1. Here's curve 2.
So the top part, when you guys are close to the number, it doesn't change with that change?
No.
So
Only if we have like just the 2 in the top. But the x keeps it out. Okay, one more. Last one. Number 18. Now this one. How do we find the horizontal asymptote?
What do you say?
How do we find the horizontal asymptote?
The top.
Find where the bigger degree is.
The bottom.
Yeah, the bigger degree is in the bottom, so if it's bottom heavy, what's the horizontal asymptote? Y equals 0. So that means the range is all real numbers, except y cannot equal 0. Now for the vertical asymptote, how do I find the vertical asymptote? Set the denominator equal to 0. And how many vertical asymptotes will we have? 2, because it's x squared. Now I need to factor that, and how would you factor that? What is it called? is x squared? And what's the square root of x squared?
2.
Oh, very good. So it has x and x. One is a minus, the other is a plus, and what's the square root of 4? 2. And after you have it in factor form, what's next? Set them equal to 0. So x minus 2, set it equal to 0. And x plus 2, set it equal to 0. So what's the first vertical asymptote? 2. X equals 2. What about the second one? X equals negative 2. So the vertical asymptote would be x equals plus or minus 2. So the domain is going to be all real numbers, except x cannot equal plus or minus 2. Now when you graph these, graph the asymptotes first. So graph your two vertical asymptotes through positive and negative 2. And the horizontal asymptote is at 0. Now this one's complicated. Why is this one complicated? We have 3 asymptotes, so this one is complicated one. Let's put it in the calculator. So in the calculator. How do I clear this? Doc C. And control divide for a fraction. We have negative 9 in the numerator. In the denominator, we have x squared minus 4. So negative 9 up top, x squared minus 4 on the bottom. And then if you hit enter, what do you notice we're going to have here? 3. We're going to have 3 sections of the graph. So what does one part look like? What does that middle part look like?
What is the square?
What is that square thing called? Parabola. So between the two vertical asymptotes, we're going to have a parabola. So between negative 2 and positive 2, we have a parabola. And then on the left side of the asymptote, we'll have a curve. On the right side of positive 2, we'll have a curve. So to get those, do Control T to look at your table. Now let's go up. So at negative 3 is at negative 1.8. So plot that point. So negative 3 is at negative 1.8, which would be about right here. Then draw your curve to that point. So just one point for the curve. And now for my parabola. I need to be between negative 2 and positive 2. So at negative 1 is at 3. At 0 is at 2.25. And at 1 is at 3. So negative 1 is at 3. 0 is at 2.25. And at 1 is at 3. So plot those 3 points for the parabola. So negative 1 goes up to 3. 0 goes up 2 1/4. And 1 goes up to 3. And connect those points for that parabola. So make sure that parabola stays between those two vertical asymptotes. Now we need one more point so that we can do that final curve. So this point should be at 3, negative 1.8. So 3, negative 1.8. 3, negative 1.8 is right here. And draw a curve to that point. Now my advice to you is to finish that back page of the assignment before you leave today, so you can use the calculator if you need it. So hopefully you'll finish everything before you leave.